Bismillahirrahmanirrahim. Welcome to the second part of the basics of matrices or algebra of matrices. In the last part, we spoke about the addition and subtraction of the matrices, how to add two matrices and how to subtract, and the condition that's required for doing the addition or to add two matrices. Now in this part, we are going to speak about the multiplication or scalar multiplication and product of the matrices. Starting with the definition of the product of real number and a matrix, if we are given a matrix A with order m by n or size m by n, we have the order for this matrix is m by n. Written in this notation, A equal to matrix A sub ij and a real number C. And this definition C is just a real number, it is not a matrix. It can be any real number, 0, 1, 2, minus 1, or whatever is the real number. Then C multiplied by matrix A is equal to C by each element of the matrix A. So we are going to multiply by any element in the matrix A by the constant C or by the scalar C. This product has some properties that we have. Distributive property, which means that if I have two scalars B plus C multiplied by matrix A, we can distribute the product A or B times A plus scalar C times the matrix A. Or if I have scalar C multiplied by sum of two matrices, we can distribute the C among the matrices C by A plus C by B. And also we have the associative property that if I have A times B times matrix A is equal to A, B times the matrix A. We call this the associative property. As a direct application for this definition and the properties which have these two matrices. We are given two matrices A is equal to minus 2, 3, 4, minus 2, 0, 4, and a matrix B, 8, minus 2, minus 3, 2, minus 4, and 7. And we need to find 2A plus 5B. First of all, the size of the matrix A is, we have 3 rows, so it is 3 by 2. And B also the same thing, is 3 by 2 columns. So these two matrices have the same order or the same size. Now 2A plus 5B. 2A is equal to multiply each element of the matrix A by 2. So I will get minus 4, 6, 8, minus 4, 0, and 8. So we multiplied each element of the matrix A by 2. For the 5B is equal to multiply each element of the matrix B by 5. So 8 multiplied by 5 is equal to 40. Minus 2 multiplied by 5 is minus 10. Minus 3 times 5 is minus 15. And 2 times 5 is equal to 10. And minus 4 times 5 is minus 20. And 7 times 5 is 35. Now we can find 2A plus 5B, which is equal to, take the element in the same position. So minus 4 plus 40 is equal to 36. Now 6 plus minus 10 is equal to minus 4. Next one, 8 minus 15 is equal to minus 7, and minus 4 plus 10 is equal to plus 6, and 0 minus 20 is minus 20, and 8 plus 35 is equal to 43. So we multiply the two matrices A and B with the scalars 2 and 5. Then we add 2A plus 5B will give me this matrix, which is of size 3 by 2. So this is the idea of scalar product. Next point will be the product of the matrices, matrix multiplication. If we have row matrix with column matrix, suppose that we have a matrix A, B of size 1 by n. 1 by n is a row matrix given by this station, and let B be n by 1 is a column matrix. So I have two matrices, row matrix and column matrix. And the size of A, write it down, A is 1 by n. B is n by 1. The necessary condition for product of the two matrices is that the number of columns of the first matrix equal to the number of rows in the second matrix. Number of columns in the first one must be equal to the number of rows in the second matrix. If this condition is satisfied, we can do the multiplication. It is row by column. I will have the first element with the first, plus second with the second, plus third with the third, and keep going in this way. The last one with the last one, and we add all of these. For example, if I have this matrix A equal to 2, 3, 5, and B is 1, 4, minus 6. These are two matrices, row matrix and column matrix. Row, it is 1 by n, or 1 by 3 in this case, and B is 3 by 1. These are the sizes. A is 1 by 3, and B is 3 by 1. And we can see number of rows equal to the number of columns. The output for this matrix will be of size 1 by 1. So the product for this one, 2 times 1, it is 2 times 1. Then 3 times 4, 3 times 4. And 5 times minus 6, this is 5 times minus 6. And we add them together. And we will have minus 6 or minus 16, which is of size 1 row and 1 column. Take this. So this is how to multiply columns or row matrix with row matrix. If you want to make it more general, for that we have this matrix A of order m by n. We have a matrix A of size m by n, and B or another matrix of size n by p. We have to be careful about these two conditions, and this condition, number of columns must be equal to the number of rows in the second matrix. Then the product of A times B will be another matrix, Cij, of size m by b. Applying the same concept of the row matrix and column matrix. So the definition for the product will be Cij equal to I1 B1J. They have the most number of the column equal to the number of rows. IA2 B2J. In up to Bnj. Each Cij is given by this formula. to clarify this point, suppose that we have this matrix, or these two matrices, A equal to 2 minus 3, 0, 4, 6 minus 1, and B equal to 1, 0, 4 minus 2, 3, 5. Then the product A times B. A times B. We will take the first row first with the first column. And that's why I have 2, 1 to this one, 2 minus or minus 3 with 4, second with the second in the column, and 0 with 3. So this will give me the first row with the first column. Then we move to the second column. Apply the same concept. 2 times 0, minus 3 times 2, and 2 minus 1, or sorry, 0 with 5 is equal to this one. We are done from the first row with the first column, and second column we move to the second row. Apply the same concept for the second row. Multiply the first row by first column, first row by the second column, and this will give me the matrix minus 10, 6, 25, and minus 16. So the idea is to move horizontal, then vertical for each row and for each column. Let's have some examples. Or speak about the properties first, then we see the given some examples. For the properties of the multiplication, if we have, or if we are given matrices A, B, C of order m by n, n by p, so we have to be careful about this condition, n equal to b, and b by q. So this b is coming in this position, respectively. Then a times bc equal to abc. This is associative property. For the distributive property, if we are given a matrices A1, A2, A sub 1, A sub 2, of order m by n, and matrices B1, B2 of order n by b. Again, we have to check these orders. Number of rows equal to the number of columns. Then A1 times B1 plus B2 equal to A1 B1 plus A1 B2. Distributive property, we can distribute the matrix outside the bracket to be multiplied by each one of the matrices inside the bracket. Same thing if we have A1 plus A2 B1 equal to A1 B1 plus A2 B2. We have left distributive property and right distributive. Left because this is left outside the bracket from the left, and right because the matrix B1 is outside the bracket from the right. And the last property will be the identity property. If A is a square matrix of order n and In, this is the identity matrix. Identity matrix, suppose that I have I2. It means I have 2 rows and 2 columns. We have 1 in the main diagonal and 0 everywhere. This is identity matrix of size 2 by 2. I3 by 3. If we have square matrix, we just write it as In. It means number of rows equal to the number of columns. If they have the same size, just we write this notation as I sub n. Means the number of rows equal to number of columns, or you can say this is a square matrix. I3 will be 1, 0, 0, 0, 1, 0, 0, 0, 1. So the main diagonal element is equal to 1, and the other element will be 0. We call this is identity matrix. Identity. So if we have a square matrix of order n, square matrix of order n, and I sub n is identity matrix of order n, then I equal to I times A equal to A. So the identity matrix plays the role of the number 1 in the multiplication. 1 times any real number will give the same number. So 1 times 3 equal to 3, 3 times 1 is equal to 3. Same concept for the matrices. The identity matrix multiplied by the matrix A will give me A. So let's have one example for this product matrices. Suppose that we are given A equal to 2 minus 3, 1, 4, and B equal to minus 2, 4, 2, and minus 3, and we need to find A times B and B times A. Let's start with the first one, A. Is 2, minus 3, 1, and 4, multiplied by B, which is minus 2, 4, 2 minus 3, is equal to, move horizontal row, multiply by column. So this will give me first one with the first one. So it is 2 with minus 2 plus second with the second minus 3 times 2. So we are done from the first row, first column. We move to the first row and second column. First row from the first matrix A, which is again, this is the first row. It is 2 multiplied by second column, 4, moving vertical in this direction, plus second element of the first row, it is minus 3 multiplied by minus 3. So we are done from the first row of the matrix A. Let's move to the second row. Second row, which is this one. So we have 1 multiplied by first column plus second element will be 4 multiplied by second element of the first column, which is 2. Let's move to the second column of the matrix B. So second row of matrix A with the second column of matrix B. This will give me, it is 1 multiplied by 4 plus 4 multiplied by minus 3. This will give me now 2 times minus 2 is equal to minus 4 minus 6. 2 times 4 is 8. This is 4 there. Plus 9. Down, I'd have minus 2 plus 8 and 4 minus 12, which is equal to minus 10, 17, 6, and minus 8. So this is A times B. So we found A times B. Let's find B times A. B is given by the matrix minus 2, 4, and 2, and minus 3, times A, which is 2, minus 3, 1, and 4. Now we revert the order. We need to find B times A. B times A, we now start with B and then A. This will give me now is equal to first with the first, so it is minus 2 times 2 plus 4 times 1. Second with the second down. Now we move to the second column. I will have minus 2 times minus 3 multiplied by or plus 4 times 4. Now second column down, 2 minus 3. 2 times 1 plus minus 3. So this is 2 times 2. With the first column will be this one with this one, 2 times 2, and minus 3 times 1. Let's move to the second column. It will be 2 times minus 3 plus minus 3 times 4, which is equal to, I will have minus 4 plus 4, 6 plus 16, second one will give me 4 minus 3 and minus 6 minus 12, which is equal to, I will have 0, 22. We have 1 and minus 18. Now let's compare between A times B and B times A. This is A times B and this is B times A. They are not equal. These two matrices are not equal, which means that the product of the matrices is not commutative. This will give me that A times B is not equal to B times A. So we have to be careful about the product of the matrices. A, B is not equal to B times A. So the product of the matrices is not commutative. We can write this is not commutative. So this is how to multiply two matrices.